In this section, we're going to look at what happens as x gets larger and larger, either in the positive direction or more and more negative, right? The magnitude gets larger and larger in the negative direction. And the first thing we're going to look at here is y equals e to the x. All right, so let's start out by looking at what happens as x gets larger and larger in the positive direction. So I'm going to start at 0 here and fill out this table. So e to the 0 is 1. E to the 1 is e, or it's Euler's constant, right? So it's 2.71883, and it goes on and on. But I'll just round it off to 4 decimal places. All right. All right. And then I can use my calculator and put in e to the 10th power, and I get 22,026.5, and it goes on and on, but I'll round it off. So now if I try to put in e to the 100, I get a number in my calculator that it's in scientific notation. I think it has like, if I wrote it all out, it would have like 45 digits. And so I'm not even going to try to write it. I'm just going to say it's huge, right? It's huge. All right, if I put in e to the 100, it's huge. All right, so let's go ahead before we finish filling out this table. Let's look at the first question. It says, is there an upper limit to the value of the function as the magnitude of x goes larger and larger in the positive direction? Okay, and no, there's no upper limit. So e to the x grows infinitely large. Infinitely. Sorry, I'm distracted by the telephone here. Infinitely large. Okay, infinitely large. All right, I think I spelled that right. All right, so it just goes to larger and larger. So we can say that the limit, well, I'll just write it down here, limit as x goes to infinity, right? We're getting larger and larger. So x is going to infinity of the function e to the x is equal to infinity. Okay? So we have an infinite limit at infinity. And then now let's go ahead and finish filling out this table. Let's look at what happens as x gets more and more negative. All right, so let's start with e to the 1, or sorry, e to the minus 1 when x is minus 1. Now, e to the minus 1 is the same as 1 over e, right? So it's 1 over e to the first power. If I put that into my calculator, I get 0.3679. Okay. And then I can keep putting in values of x. And e to the minus 10th is 1 over e to the 10th power. If I put that into my calculator, ooh, it's kind of small, 0.0000, let's see, 45. Okay, so it's pretty small. Now, if I put in a negative 100, it's so small I can't write it. It's in scientific notation. I'm just gonna write tiny. It's tiny. So it's practically 0. So is there any value of x for which e to the x is 0, right? Now, if you're raising e to some power, right, it's always going to be positive, right? Because e is a positive number. It's 2.7183, blah, 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 right? So we raise it to any power. If I put in positive powers, it's just going to get bigger and bigger. If I put in negative powers, we're just looking at the reciprocal, right? So I got 1 over e to some power. And so there's no value. So I'm just going to say no. No, there's no value of x that will make e to the x equal to 0, although it does get pretty tiny when you put in large negative numbers. I mean, it's practically 0, but technically it's not 0. So is there any value for which e to the x is less than 0? So negative, right? Less than 0 means negative. And that again is no. No, e to the x is always positive. So no, e to the x is always positive. Okay. All right. Next question, is there a lower limit to the value of the function as the magnitude of x gets larger and larger and larger in the negative direction? Okay, so you can see it's getting smaller and smaller and smaller, right? It never goes negative, so it's approaching 0. So we're going to say, yes, yes. E to the x never goes below 0. Never goes below 0. 0. Okay. Or we can write this as the limit as x goes to negative infinity, right? As x gets more and more negative, e to the x goes to 0. So in the limit, it is equal to 0. But only in the limit. It only approaches 0. It doesn't actually go to 0. All right. So based on that, let's see if we can figure out what the domain and range of this function is, right? The domain and range of e to the x. So let's first of all start with the domain. So remember what domain means. It's the set of all input values, so our x values. And so are there any x values that are off limits, right, that we can't put in? And, we saw up here in our table that we can put in whatever we want, really. I mean, this is only a sampling of what we could put in, but there's no x values that are off limits. So I'm going to write this using interval notation. I'm going to say x is an element of the set negative infinity to infinity. So I'm just using interval notation to write the domain. Okay, and the range, now that's the set of all output values, right? So that's our y values if y equals f of x, or y equals e to the x, right? That's what we called it. So y, what's the range? What are all the possible output values? Now we said it never goes negative, right? And it's never equal to 0. So it seems like our lower limit is 0 and it does not include 0. But the range, it can go as big as we want. So the upper limit on the range is infinity. Okay? So when we look at these limits at infinity, it's called end behavior. The end behavior of a function is the behavior of the graph of f of x as x approaches positive or negative infinity. So we can write the limit as x approaches infinity, or the limit as x approaches negative infinity. So when we talk about end behavior, we're talking about these limits at infinity, either positive or negative infinity.